What's this current?
It's 2.4 over 100, which is 0.02.
It's in the microamp, right? That's a good way to ignore that current. It says ignore the current, right? Now, let's see. If this is 1 milliamp, we said this 1 milliamp, this current is 1. 0.01, right? It's equal to IE. I sub C is equal to IE, right?
Yeah.
What is this voltage? VC2? Approximately, or not approximately, what is it? It's 10 volt minus the current, this current, right? Which is 1.01 milliamp
Times 2K. Yeah.
times 2K, 8 volt approximately. Right?
Yeah.
If that's 8 volt, what's VCE2? That's the Q point. No. What's Q2? This is, we already found, this is 1 milliamp. This is VCE2. What's VCE2?
Is that the difference?
It's 8
Oh.
minus 1.
This is
volt
8,
Is 7.
8 times 7. 8 times 7 is
7, right?
Yeah.
8 minus 1 is 7 volt.
That's right.
You found the Q point for 2. All right, now let's go back. How about the Q point for 1? What's the current?
We found it.
0.01 milliamp.
0.01 milliamp. What's the voltage?
6.3.
It's the difference between 2
This
volts.
is 7 volt,
Oh.
1.7,
7 minus 5.
6.3 volt.
5.3, sorry. Wait, you said
You
it's
found the DC operating point for both transistors very quickly,
8 volts.
okay? By doing some smart, ignoring some stuff. You don't want to write base loops and all and go all that stuff. It gets really hairy for 1% of the number.
Can you explain how you got VCE2 again?
VCE2,
Yeah, VCE2.
this is VC2,
Uh-huh.
this is VE2.
It's the track.
Oh, no, not just VC2, not VCE2, just VC2.
The total voltage 10 volt minus
The voltage
2
drop.
times the current.
Yeah,
So 10 volt is the DC.
you got 1 milliamp, 0.01 milliamp,
Times the resistor.
10 minus 2, 10 volt minus 2K
Okay,
times the
right.
current.
The voltage drop
Yeah.
in the resistor.
I didn't do the 10 on that.
Mm. All right, suppose you want to do DC AC load line on the output stage. You don't care on the input stage, okay?
Okay.
The output stage is where you tie RL. Okay? Now, what about DC load line of 2? What do you have? 10 volt equal. Right here, you could ignore these, right? It's essentially is IC2 times 2K. In other words, this is IC2. This is really approximately IC2, right? I'm ignoring 0.01 of it, 1%. So it'll be IC2 times 2K, and you keep on going, 1K. Plus the voltage drop here, VCE2. Those are the values. Right? That's a DC load line.
So you just open the capacitor, right?
Huh?
You just open the capacitor. for
Yeah, the
DC.
capacitor is open.
Okay.
How
So
about
what we
AC?
have-
How about the AC load line?
We showed them.
Okay, you're going to have IC total of 2 minus the current, which is 1 milliamp. What's the impedance that sees? This is short, right?
Yeah, 2K.
You see only 2K
It's okay.
plus VCE total minus the voltage 7 volt equals 0. You got it?
Can you see how it would look like for AC load line? How the circuit will look like?
For 2. It looks like this. Right? This is a 2K to ground. We ignore that part. Okay? That, right? And this is little IC2.
So you're doing each one individual, right?
Huh?
You're doing each one individuals? Like for Q1 and Q2?
I'm doing only 2.
Okay.
I don't care about 1 because 1 doesn't tell me anything. 2 tells me because you put RL here, that's where the swing gonna happen.
Let's see.
1 is barely moves because it's a high gain kind of thing.
Okay.
Now you plot these, VCE and IC. The first one will be a 10 volt, right there. And the current 3.3 milliamp here, right? You put this to 0, 10 over 3, 3.3. This is 10, and this is 1 milliamp. This is 7 volt. That's the Q point. Right? Now for the second one, it'll be 7, if you put this to 0, it'll be 7 divided by 2K, 3.5 plus 1, 4.5. So it'll be 4.5 mil.
Then we see
You
the
put this
IC
to 0, it'll be 9 volt. This is 9 volt. Right? How much swing can you do on the output? Symmetrical swing without clipping. How much?
2 volts. You can go up.
It
You
could
up
go
two,
to the right 2 volt,
or to the left 2.
to the left 2. So it could do this. And this would be 4 volt peak to peak, right? 4 volt peak to peak swing. Okay, if you overdrive it, it could do more here, but what it would do, it'll clip on one side. So for it to be an amplifier, you cannot overdrive it more than 4 volt peak to peak swing. So you have to adjust the V input signal. The gain is fixed already. Now, how do you calculate the gain? Let's draw the small signal equivalent circuit, and from there we can go calculate gain, right? Start from the left to the right. Here's a collector of 2, emitter of 2, and base of 2. From there to there, this is a PMP, this is beta IB, here's R pi 2. And here is the emitter. I'm ignoring R out. Remember, R out goes here. Okay, but R out, I'm assuming, is very large. Okay, now, where's the emitter of 2 going? Take a look at the picture.
It's going to the resistor on the ground.
Goes to ground. The resistor is shorted out.
That's right.
So here's emitter of 2. Here's a collector of 2, goes what?
Collector go to the 2K.
You have 2K here, and you got something going somewhere. Right? Now let's draw the input circuit. The emitter goes into the base, so here is R pi, no,
So you have R1 and R2 in parallel.
like that, right?
Yeah.
And this goes there,
And you have the 38 and 12.
and I have RB, and here's VN.
So RB stand for the 38 and 12.
Huh?
So RB is for the 38.
Yeah,
and
the 12 in parallel
And
with it.
12. Okay,
Because it makes no difference here because VN is straight in.
okay,
You see that?
I see.
All right, we have one relationship. This is what? IB2. What's this current, by the way?
0.3 plus
No,
1.
no.
Beta
What?
plus 1 IB. 1.
What's this current?
Beta plus 1.
This is IB2, right? It's equal to what? Beta plus 1?
IB 1.
Right?
Yeah.
Okay. Now, V out over Vn is equal to V out over IB2,
Times IP
IB2 over IB1,
times IP1.
IB1 to Vn. What's this current?
Yeah.
So IP is
Beta IB.
Right? From this relationship. Okay? So, what do I need to do? I'm redrawing it. I didn't do that for the other classes, your special class.
Yeah.
I'm gonna redraw it. Oh, no. Yeah, that's correct. All right. Right? Now you have to tell me what RA and RB is. What did I do here?
Impedance mirroring.
I did impedance reflection. What's RA?
Say the 12.
It's IB.
I did that for the other class as well. They asked me to do it one more time. Here's impedance reflection again. We call this VE. This is beta IB, and this is IB. Okay? I can break this into looking like that. That's what I did here with this resistor. Right? Now, here's RA, here's RB. There's beta IB, and here's IB. And this is here's R pi. VE on this side, VE on the right side is equal to what? Beta plus 1 Rx IB. Here. VE on the other side is equal IB RA. right? On this side is equal to beta VE is equal to beta IB R
Or RB.
beta IB RB, right? Now I want to find RA. I compare this to RA, to this. What's RA?
Beta plus 1.
Beta RB over RA.
Compare them straight out. What is it? You said something. What is it?
Beta RA over RB. No.
Compare. There's no B there. Compare this to this. There's no RB.
Beta plus 1.
Beta plus 1.
And I'm going to put it here. Let's put it IB
Beta plus 1.
RA.
Yeah.
What do?
Beta plus 1RX.
What's the value of RA?
Beta plus 1RX.
R.
Right? So this is beta plus 1 Rx, right?
Yeah.
Right? Now, well, not in this case.
No, RB.
Beta plus 1 what?
Whatever the resistance was.
R by 2.
R by 2.
In here, what's this? It doesn't matter.
Just R by 2.
Approximately R by 2. Beta plus 1,
This one.
beta over beta plus 1. So this is R by 2. Right? Now you're ready to do that. Without this technique, you'll be here for 6 hours going in loop analysis. You have to write a loop. This way, and that way. Okay? Can you tell me what this number is?
It's R by.
First of all, it's a resistor. Right? It's a voltage over current, so it's a resistor. The resistor is what? It's the 2K. And it's minus. What's the current?
Why it's minus?
Because the current going down.
So
If this is IB2 and this is beta IB2, so minus beta plus 1 IB2, right?
yeah.
Okay? What's IB2 to IB1?
Beta plus 1 IB.
Beta plus 1. Okay? Now, what's the last ratio? There's 1 over the resistance, right?
1 over R by
In
2.
parallel with RB.
1 over R by,
Oh.
here,
Oh.
R by 1
I 1.
That's R.
plus
RA.
RA.
beta plus 1
R by 2.
R by 2,
That's RA.
right? Now you could, what's R by 1? It's equal to 100 times 25 millivolts, divide by the current, which is 0.01 milliamp. R by 2 is equal to 100, that's beta, 25 millivolts by 1 milliamp, which is equal to 2.5K. And that one is equal to 250K. But 2.5K times 100, okay? This gives us, I mean, if you divide the beta, then you can get it. The answer is minus 40. Is this clear?
That's mean we got a negative gain.
Huh?
That's mean we got a negative gain.
We got a negative gain, right? Yeah, it's a negative gain. You know how it's negative gain without doing all this? gain means what? What does it mean?
180 out of phase.
The output 180 degrees out of phase from the input. Okay, let's go back here and let's see what happens. If I increase this voltage, what happens? What happens to the current here?
It's gonna be less.
Here in the emitter. It's gonna increase, right?
Okay.
If they increase the current in here, what happens in here?
Also gonna increase.
Huh?
Also gonna increase.
It's gonna increase the current in here, so the current will go up. That means, what happens to the voltage?
The voltage drop over there.
No, I'm talking about voltage, okay? If I increase the voltage here, the current, the voltage will go up, and this
Voltage
voltage
will
goes
go down.
up, and the current goes down, so this will be down. So it'll be 180 degrees out of this. Put that to rest right now. Yeah. Any questions? I haven't asked anybody to come to the blackboard. Who can come to the blackboard? Nobody?
John,
I just like talking to
No
myself.
one? Who made over 90 on the first, the second test? Nobody's gonna admit now. The highest was the highest was 95.
the highest one's 95, the
That's
second one's
humble.
90. The second one got 90.
You got 90?
Okay.
I think it was 92.
92 or 95.
There were 4 or 5 90s, I think.
They were all in the first section. The
Yeah.
section's a little bit.
Oh, no, we might have one.
Why? Because this is after lunch?
Yeah,
No, we don't.
we're sleepy. Too much chicken.
This is really where the fun starts. It's just you got to get into it.
Your definition of fun, not mine. I just want to clarify on that.
Okay? Are you computer or electrical?
Computer?
Computer. That explains a little bit.
I got a
last
seven.
Justin got
electronic
one.
class
Stop
for
it.
computers.
I got a
Said he
seven.
wants to go up.
Okay.
Is it more fun
Oh, like the
than
last circuit
fields?
class.
I brought the chalk, so,
Yeah.
you know, I get it.
Huh?
I brought chalk.
It's more fun than fields, right?
Yeah.
I'm doing better in this class than fields. Or modern. Or another guy.
You're doing better here than fields?
Yeah, but that's just because I
I
said.
just saw Ebon on the way.
I
He
just-
said he tried to integrate the square root of something.
Oh, it's the trig
Square root of X or so, I don't know what he's integrating.
Wait till chapter 9, it's circuits and fields.
We already.
Fields is a hard course to teach
Yes.
Yeah.
because the audience is not there. I'm sorry to say, you're not a field guy.
No, I'm not a physics guy, so I'm really bad at
Yeah.
it, actually.
And that's what happens, it's just the wrong audience.
Yeah.
If you're a physics major,
Yeah.
it's the correct audience. This is probably not the correct audience for computer engineers either. But you got to know something beside your field.
Yeah, it's good.
That's what it takes me, yes, for all that.
We did something else.
Barely swam.
What?
He says you're not the audience.
Okay, let's do another problem.
He said, I agree.
I guess today I'm not gonna ask you to come up. Tomorrow, on Thursday, I will.
Oh, okay.
You have a
So-
test?
Yeah.
He came up. On the
You want me
Sisyphus.
I can, but you gotta help me through it.
Same, I'll come up.
You're not ready.
Oh, swam.
Oh, I'm
He just
not
said
ready.
it.
Oh, there we go.
10 years ago. so-
All right, here's another problem. This one is PNP. All right? There's nothing about it except we reverse the voltages and the currents.
Yeah, collectors up there. The bottom.
The top. Oh,
And you just rotate the tape.
You rotate there.
Yeah, the base. Oh. I just say follow the.
The outward arrow, right?
It's the handout he gave at the beginning. He has more up there.
Oh,
I've got one of those.
Yeah, there's a bunch of. Here you go. I'll look at glasses.
Okay,
No. I just-
BMP. And here is two K, and this is the out. Do everything. Find the DC conditions, and find AC, DC load line for Q2, the output stage. All right? Where do we start? Ignoring base currents and ignoring R out. Where do you start
In Q1?
to calculate things? Where do you start?
Q1 base.
I could DC current, DC voltage here, right?
Yeah.
that's right.
What is this voltage?
Voltage division, 5 times 10, 50
On
over
those 2 points.
15.
What?
50 over 15.
Yeah. 10 over 15.
It's 5 times 10, 50 over 15.
Wrong.
10 over 15.
This is minus 5 here.
Oh, I didn't
Yeah.
mention that, okay.
You
Don't jump too quick, okay?
Five
It's
minus
VBE1 here
Uh,
is equal
this
to
is
5 volt minus
-5.
the current
Oh.
That's I times 5K.
minus 5K times the current. What's the current?
It's 10 over
10
15
volts over
15.
15,
Mm-hmm.
right?
Yes.
15.
That will be 10 over 3, 6.7 volts, right?
5 minus.
Wow.
Wait. 5 minus 3 over.
Right?
2/3 times one.
Did I get it wrong?
1/3 of 10, so it's minus 3 over 3.
Oh, what the hell? This cannot be 6.7.
Yeah.
Cannot be higher than 5.
Yeah. So it's 1 point.
It's 5 over 3. It's 1.3. 3.7,
Yeah.
right?
Is it 1?
If this is 3.7 and I'm neglecting the base current, where do I go from here?
Is it, would it be 1.6, 1.7?
Because it's 5 minus 3.3.
What's 2/3
I
of
got 1.6.
It's 1/3.
1.7.
Yeah.
Okay, 1.67,
Yep.
6.3, whatever, 1.7.
Yeah.
All right, where do I go from here?
What would you say?
Take a look at the diode. Where'd I go?
We go to the inverter.
This, what's this voltage?
It's
Yeah,
the
it's
voltage that we get 1.7 minus 0.7.
Wrong?
It's 3.3.
5 minus.
You go up or down. Look at the arrow.
Okay, so we add 0.7.
Oh, you need the second term. Yeah.
This is PMP. Look at the arrow. If this is 1.7, what's this voltage?
2.4.
2.4 volts.
So,
This is the current. Remember, here's the current.
Yes, that's right.
That's the way. This is PMP.
That's right.
Yes.
All right, 2.4 volts. So that, what is this current then? IE1.
It's Ohm's law.
It's 5 minus 2.
Plus 5.
Right?
That's correct. Yeah. Yep.
We don't have to roll 5 at 5.
No, because there's a voltage drop with that.
Now, from there, where do you go?
Because we neglect the base current.
You go to this.
So IE1 will be equal to IC1.
Yeah.
Approximately
Approximately
IC1.
equal, yeah.
What is this voltage?
It's the
minus 5 plus the current times,
Right.
so this voltage will be minus 5 plus 0.8 mil times 5K, right?
Right.
It's equal to minus 1 volt,
Yeah.
correct? This is 1 volt. Now, what's the Q point for 1? We already gotten what? The current 0.8. Here's the catch. This is not VCE, this is VEC.
Oh, it's still top to bottom.
Right.
It's a PMP, you have to reverse those. What's VEC? 2.4 minus 1, minus 1. You cannot get a negative number there. 3.4. So that tells you VEC, 3.4 volt. All right?
So
Now-
section.
This is minus 1. What's this voltage?
It's minus 1, minus 0.7.
So minus 1.7 volt. Right?
Yeah.
What is this current?
It's, so it's, minus 1.7 plus 5 over 1K.
So IE 2,
6.6.
is this 1K or 4K, I think? Sorry, it's 4K.
So it's minus 1.7 plus 5 over 4K.
All right?
Micro.
Now, what is VC2?
VC2,
EC2 be 5 minus where's that? 0.8, yeah, times 2.5.
I think it's 2.1.
so we assume IC equal to IE, right?
Yeah.
Okay.
Is that right?
I think it should
5 minus 0.8 times 3.5, 2.2, that's right.
Yeah. Yeah.
Now, how about Q2? Remember, it's VCE to IC2.
So that's been 2.2
This
minus.
is 0.8. What's this? This is in milliamp.
The different voltage, 2.2, minus
2.2 minus 1.7.
That's right, that's the
3.9
3.9.
3.9 volt.
Yes.
Now you got the conditions, all the DC conditions. Now you can do DC and AC load line on the output. DC load line on 2. You have 5 minus 5, it'll be 10. And this is open, 3.5 plus 4, 7.5K. I sub C2 plus VCE2. That's the DC load line. The AC load line, you short this and you short that. You'll have, I'm skipping a step here. You have IC total minus the current, 0.8 mil. What's the impedance here? 2K in
plus
parallel with
3.5.
3.5K. Plus VCE total minus the voltage 3.9 volt. And you could plot these, right?
I have a question. I just don't know why you ignore Q1.
Ignore it.
Yeah.
I'm not ignoring it. I'm gonna find out how the output's swinging. The output stage is Q2. That's where the load is,
Okay.
okay?
So we always look where's our.
Yeah, but you have to make sure Q1 is not clipping. But before, in other words, if Q1 has gain in it, so you put voltage, and then you get an Q1, you get an output say like this. You don't wanna get an output
Clipping.
looking like this, then it'll clip on the outside. Yeah, normally, the gain of the first stage is low to avoid this. And the gain of second stage is where the gain is. And that's what multiplication of the two give you very high gain. Okay? You could plot this, right? Hopefully, we all know how to plot these. This one, 10. This would be 10 over 7.5K.
That's when BC equal to 0.
And the Q point right there, 3.9. This is 0.8. Mil,
Intersection.
3.9. And this one will be, what's this? Combination, I don't know.
Let me find it.
Negative 1.7.
2 times 3.9 over 0 plus 3.5. It's 1.2, 1.3.
1.3K. Okay, this is 3.9 divided by 1.3 is 3. Plus 0.8, it gives us 4.7 milliamp, right? Somewhere here. Okay? And this goes like that. That would be 3.9, 1.3 times two, about 4.9. About, I don't know.
So this one is gonna be 2. Peak to
Huh?
peak,
It's gonna be swinging only plus or minus 1 volt, so
which
what?
is 2 peak to peak.
2 volt peak to peak. It's not, it's loaded down, that's what it is. All right. Now I want somebody to draw the small signal.
Oh, no, I'm not good at this.
Come on, man.
Find
Or
it.
ladies.
Sure. Get this.
1, 2, 3. Ladies.
Ladies.
4.
Draw, so,
Who's gonna go through the small signal?
You what?
Just,
Draw the small signal equivalent circuit.
whenever I have questions.
That's gonna be on the quiz on Thursday.
Just answer all my questions.
Not a brave man here, or woman. The big guy, come on up here with that crazy looking phone. I'm
Am I
gonna
gonna
help
get
you.
assistance on this?
Yeah, come on, I'll help you.
Okay.
Your friend man.
You draw well.
This is the real bread man.
I'm a bit rusty at this. What we working with? We're supposed to be doing this together.
I want you to draw the small signal. Let's start here. Let's erase this, okay? Erase this so that they will see, not the circuit, okay? We got all this, right? Huh. Okay, here, I'll help you start it. Collector of 2, base of 2, emitter of 2. From here goes beta IB2, and here's R pi 2. Now, go from here.
Yeah. So you have a resistor and a C2.
Yeah.
What is connected to collector of 2?
You have 3.5.
Yeah.
3.5.
Take a look at the circuit.
R out, this is.
What's connected to collector of 2?
Just branch the resistor.
Right.
Where's collector of 2?
On the right side.
That's emitter of 1.
C2 on the.
That's it, yeah, that's
There
it,
you go.
that's it. You put your hand on it.
Look at that.
Put your hand on it.
Down
That's
there,
it,
there.
that's
Put
it,
your finger
3.5.
down there, not here, yeah.
That's the resistor.
Alright.
Is that, where's collector of 2? Where's Q2?
That's it, yes.
Where's the collector?
That's it. He put his finger on it.
Where's your finger is?
yeah, right there, that's the.
That's right.
That is
That's
the
the
collector.
collector.
What's tied to that?
The resistor, 3.5.
Yeah, those are 2 parallel, right to ground.
Yeah.
Put them up here. To the collector of 2 to ground. A resistor, right?
Yeah.
In parallel with the.
2K.
Oh, no.
You only draw.
Yeah, this is in
You
parallel.
can draw a straight line, Michael, you know,
Straight
Michael,
line.
this is my son.
What?
Like, shout out my son. I called him Michael, my son.
You're right. Just to ground.
You are like my, some of you are like my grandkids.
No,
Oh, yeah.
that's in series.
What happened to
No, and the other
capacitor?
one. They connect the other one, right?
No. So,
Come Muhammad, come
In
help him.
parallel.
so just draw this and this in bundles. You just draw a line. You know,
Draw a line, the capacitor is short.
Yeah.
Yeah, come on.
Down.
Where's all the juice?
I'll go down.
Down.
Go
Okay,
down.
you got 3.25.
Just draw this capacitor in here. Okay. And then.
There's no capacitor, man.
Just a resistor.
Just a
The
resistor.
capacitor
It's
is
shorted because it's AC.
Yeah.
Yes.
Mike.
It's
There's one more there's one more resistor.
The other one, 2K.
The 2K, right?
Oh, yeah,
You
okay.
used it.
Sim line. Yeah, that's right.
You gotta wake up by Thursday, man.
By Thursday, I'll be up on
No, go down. Don't go up. Glasses. Don't go up.
it. I'll go up.
Yeah.
But you don't have
in
to go
parallel-
up, look at them parallel.
Just put it right next to it. Right next. Yeah, that's right.
Oh, man. What am I talking about? You guys way behind me.
I told you I was a bit rusty.
Okay. How about the emitter of 2? Where does it go?
Emitter of 2.
4K.
Yeah.
So you have the
The 4K, yeah.
Yes, you have the 4K.
That's it. And the capacitor.
What does the capacitor do?
Well, it's gonna short it. So that's
Short
So
it
it's
again.
just the ground.
So all we
It
gotta do
just
is
goes
worry
to
about the
ground.
resistor this time, right?
No, there's
No,
no
no.
resistor.
It goes to
So the
ground.
emitter of 2 is sitting where?
Just the ground.
The ground. Okay. Now, where's the base of 2 goes to?
to the
From
Q
Q1.
collector. To
Yeah,
collector.
draw the equivalent circuit of Q1 first. Like I showed you.
Collector. Just
Like I
right.
did, collector, base, emitter, draw that.
Come off the line of retail.
So just do this.
You want me to draw the from Q?
The pi model. Don't go so far over there.
Glasses. Just draw this one.
Draw that.
So CBE. Just put CBE.
All right, just draw
Just draw
that.
this. Exactly. Just draw the whole thing again.
The whole circuit again.
Yeah.
No.
Don't ground it because it's not ground.
Just draw the model. We
Just
don't
the
know
model.
if it goes to
See?
ground or not.
Yeah. So you have beta.
I'm sorry. Am I shouting at you?
No,
My
I'm
son.
just
My
confused.
son.
I'm confused there.
Somebody beside Muhammad come help him. You come help him.
Go, John.
All right, what we looking at?
So just
We're
put
looking
C2.
at this tag.
Help him, show him.
Alright, so this is Q1.
Yeah, let's just put the model first.
R pi, and then.
Right, you need to draw the
Put the
beta.
current.
The emitter. Yeah, so beta.
Yes, draw
Yeah.
the beta.
Losing chunk on that.
So P2, B1,
Base 1.
just B1,
B1,
and then C1,
C1.
and then you have.
All
beta.
right, hold on. This is PMP.
So P goes up, right?
Where's the current directions?
Goes up.
Emitter to collector. Look at the
That's right.
original picture.
Yeah.
See how they're going from emitter to collector. See where the emitter is?
That's right.
You're pointing at the wrong Q.
Oh, you talking about Q1?
That's
Yeah,
right.
this
Yeah.
is
The
Q1.
collector's on the bottom.
Emitter's on the arrow.
Yeah, okay. So beta IB1 would be up, right?
That's right. From emitter to collector.
Because the emitters.
That's right.
Okay. Emitter so it'll be up. Emitter to collector. Boy, you got a lot of speeding to do.
Speedy.
Yeah, to get to the level you need to get to.
We got this.
So now you have.
Right, beta IB1.
Yeah, IB1.
So now you have a resistor.
Okay, how about RPI1?
Is it still going to the 5K resistor?
Yeah.
Or collector?
What's RPI1? Okay, what's the current direction of IB1 in RPI? Up, right?
Yeah, up into the corner.
Okay, put the arrow up, IB1. Not there, on up by 1.
Yes.
There you go. Put IB1 next to it, next to the arrow. Okay, now let's make decisions. Where's the emitter of 1 goes to?
It's short.
Emitter,
capacitor, so it goes
you
to
have
ground.
you have a resistor.
You have a capacitor.
Yeah, okay, so it's gonna be short. So it's
Okay, the
gonna
emitter of 1 goes to ground, right?
be wouldn't be 5? Oh no, if it's shorted, yeah, it's gonna be grounded.
Okay, where's the collector of 1 goes to?
There's a
To the
5K
resistor.
resistor.
You have a resistor 5K.
If you ignore the base current.
Okay,
There's the 5K.
and where does it go to?
Oh, the base of, oh, there's a
So the
resistor
base-
between
the base-
base 2 and collector 1, there's a 5K resistor.
Right, right.
So what we doing?
Connect base, collector of 1 to base 2.
Base collector.
Collector of 1 to base 2, yeah, just draw, no, no.
Base
yeah,
2.
that's
Go
right.
there,
And then there's
and there's what?
a 5K
There's a
resistor.
5K
5K
resistor.
resistor.
There's a, my,
That's right.
Down.
no,
To ground.
It's in,
down.
it's in parallel.
Man, I made a mistake in the other lecture. I didn't see the 5K, put down.
Put it down.
But
One,
yeah,
5K
just-
there in the
5K
middle.
to
Yeah.
ground.
Oh, so I had it already.
No, just
No,
give
you
it,
didn't have, not 5K, this,
Just-
5K for there,
It's
the
all
ground.
the same.
Oh, like you're talking about like this.
that's
Yeah.
right.
That's
Yeah.
right.
Ground,
To
ground.
ground.
To ground.
That's a made a mistake in the other class. I didn't have, I left that one out.
You trying
But
to
that's
trick me
okay.
up. You tricked up on me.
Now, what goes on the base of 1?
This one, you have two resistor, you have the 10K and 5K
In parallel.
in bottom.
Yeah, okay, put them in.
So no,
Parallel.
no,
Not, my God,
for
man, a
B1.
base of 1.
B1,
Base one, there's something parallel.
Base,
Yeah.
where's base 1?
that's it,
B1,
yeah, draw a battle resistor.
It goes to the input. Help him out.
Oh, yeah, you got it.
How would I connect this? How would I
Draw a line,
To the left.
yeah, yeah, yeah.
And then go down.
Go down for one resistor, that's right, draw a resistor, and then,
And call it RB, whatever you wanna
Yeah,
call it.
5 parallel with 10K. So
no, it's not connect, is
It's
it
okay, it
grounded?
doesn't matter.
Yeah, it's a grounded.
Where's VN?
It's also connected, so B is.
Where's
connected
VN?
to
It is on
B1 also.
left.
In parallel with that resistor.
Yeah, just put it with B1, VN.
Yeah.
No,
No.
no, the other
No,
way.
no, no.
The other way.
The
Yeah.
left.
Show him.
Yes. So it goes like.
Yes.
In parallel.
In battle, another one.
Another parallel?
Yes.
Yeah, just the.
VN, look at the
VN.
circuit, you're duplicating
Yes.
the circuit.
Cause that capacitor.
Oh, you're talking about this right
Yeah,
here?
'cause
Yeah.
that's right, so it has to connect B into the base.
They trying to trick me. Oh, that's-
Oh, no, no, you have another resistor?
Which one?
Well, RB is,
RB is a sum, yeah.
Yeah.
Okay.
Okay. Now we have drawn the small signal equivalent circuit.
Yeah.
You come up here.
Me?
No, not you. The Russian fella.
The Russian. German.
German. Oh, German, that speaks Russian. Where's the Russian guy? He's not here.
So you have V out over
Your
V.
KGB.
That's all comes in.
Now we're calculating V out over V in.
Okay.
Write the chain. Here, I'll help you. V out over V in equal. You're a brave man.
That's what I told him, I was like, you're brave.
Okay, it's gonna be V out over IB2. I'm helping you out.
And it's gonna be IB over,
This is much
Then
nicer.
IB2 to IB1.
and then IB1 over VN.
IB1 to VN. Okay, what's V out over IB2? Take a look at the last circuit there on the right. Minus beta, that's V out, that's right. It'll be minus beta equal minus beta
Plus 1.
times whatever, 2K in parallel with 3.5,
Yeah.
2K in parallel with 3.25K.
Yeah.
3.5, yeah.
I-
All right. How about IB2 to IB1? That's what I made the mistake. I didn't have the 5K.
IB2 to IB1.
It's current division,
Right.
right?
So you have beta,
There's IB2. Okay, and there's IB1 there.
Where's IB2?
Oh, wait, it's supposed to be.
Here's IB2 there.
Beta.
Coming
Okay,
down.
yeah. Come down.
current division, right? And it's plus beta 5K divided by 5K plus R by 2. Do you buy this?
That's just that.
You buy that? Here.
Because the current's so flow.
I,
Current is deep in the current, so.
R1, R2.
But there's current. Modern, yeah, it's current.
What's I2? What is I2?
It's, I minus, the voltage over R1 times I1.
Right?
Current division.
Okay? So? Right?
Yeah.
It's the opposite resistor over the total resistance times the current. But we have a beta factor here. I gotta correct it in the other class. All right? We got it?
Sounds good.
What's the last one?
It's,
Beta plus one.
IB2 over VN.
Oh,
The last one, yeah.
Right?
Usually 1 over.
And that's it. Yeah, Vn is 1 over R pi, right? You see this, you gotta master the chain. Otherwise it gets really hairy. You have to know voltage division, current division, and Ohm's law. For God's sake, that's all you need to know. And sometimes superposition.
Sometimes.
Well, we did superposition because DC and AC is solved separately.
Yes.
And there's an answer here. I don't know what the answer is. Okay. Expect to find the gain on quiz 6 with a small model.
We're gonna have.
Doing both
stage.
pi and t or just this one?
We're gonna have two.
We will do the model the
Later?
next 2 lectures, yeah, but not,
Oh, in the
not this
quiz.
time.
Are we gonna have two
Just five
PGT
more.
or only one?
Huh?
We're gonna have two or one PGT?
What do you like?
One?
4.
I think one would be,
If he does one, he's gonna do something else to check it out.
I think one is.
All right.
It's gonna be.
You guys not reading.
I am, but it's pretty
I
complex.
read before the.
That's out of my
quiz and
jurisdiction.
test.
You read before the quiz and the test?
Yeah, a couple days before I'll start, like, really reading heavily.
Is that how you do in all classes?
Yeah. So like accelerated classes.
I don't always read.
In other words, you don't keep up as we go along.
I try
Not
to.
always.
You got like other classes to focus on.
Like, if I
It's
have
just I got other
homework, that's
classes
typically
too, so
what
I put my.
So you study in bursts. When your tail has been stepped on, then you study. You got a test coming up.
Pretty much.
Yeah.
That's not right.
Well, you got fields, so.
Not pre-lab.
That way you don't get it very, I mean, if you study it in segments like this,
We should
course
study
is
after
over, you
class.
forgot it.
Yeah.
Yeah, there's too much stuff to study for every single class. Every single class has.
The only one I could do that, what you're talking about math, when I was in college, I could do math like that. But the rest of it, I've always kept up with. Math, I was very good in math, so
I work on the first.
Okay, I'll see you on Thursday with a quiz and of course, more problems.
Who we gonna contact? Well, he's a graduate.